For this Pencast, I chose a simple mortar. The spring constant is 667 Newton meters, and the ball is compressed 25 centimeters, and when it's released, the ball reaches H max. There's no friction and no air resistance. All movement is vertical. Part A asks which of the following is true. The two that were true are mechanical energy is released, no conservative forces perform work on the ball. Non-conservative forces are forces that work against the motion of the ball, such as friction and drag or air resistance, which we know don't take part in this equation, so that one is true. The other one that was true is forces of gravity and spring have potential energy associated with them. We know that's true because at E1, the spring has potential energy, and at E3, gravitational energy has potential energy. For B, it asks us to find the speed at which the ball leaves the barrel. We know that E1 is equal to E2, so we can use this to solve for V. If we find E1, which is equal to gravitational energy plus spring energy, which is 1.5 kg times 9.8 meters per second squared times negative 0.25 meters plus 1/2 times 667 Newton meters times 0.25 meters squared. Solve all this to find E1, which is 17.16 joules. If we plug this into E2, we can find V. We set E2 equal to 17.16 joules, and that is equal to 1/2 times 1.5 kg V squared. If we solve for V, we find 4.78 meters per second is equal V. For C, it asks us to find the H max. We already know that E1 is equal to E2, which is also equal to E3, so we can use this to solve for H max. E3 is equal to just gravitational energy, which is 1.5 kg times 9.81 times H. If we plug in what we already know, that E3 is 17.16 joules, equals 14.72 newtons times H, and we solve for H, we get 1.17 meters equals H max. Part D asks, if you want to increase max height, what helps? The first option that was correct is increasing the spring constant. By doing this, you're increasing the force that the spring acts with. Second that was correct is increasing distance the spring is compressed. This increases the amount of work that the spring does on the ball. And then the last one that was correct is decreasing mass of the ball. By doing this, you're decreasing a force that is working against the spring.